Hey everyone, welcome to the series of System Design Foundation course. So far we have seen how we can scale the server, so scale the web tier, that is this one, so that our application is equipped with all the things that it can handle the increased amount of loads that is coming on our website. We also understood that scaling web tier is not enough to have the scalability things in place, because all the components that we have in our system, every component should be equipped to take care of the increase in load. So we have taken care of this layer. The next layer is the database. Very important. Whenever we have to persist the data we have to persist the data, basically data tier plays that important role in here. So what we are going to understand in this video, we are going to see there are different kinds of databases. We will see that also, database replication, how we can use it and how it will help us to achieve our purpose, how it will be helping us. Database scaling, vertical or horizontal sharding concept, we will be touching base upon this one. So let's come back to this one. So when we talk about structure of the database, like let's color it a bit, basically. So when we let's talk about the data part, like what sort of data that we have. So the data can be of the form, let's say it can have structured data, structured, and at the same time it can have unstructured data. Okay, let's start. Unstructured data. These are the only two categories that comes into picture when we talk about the databases. Historically, whatever data that we have when databases came into picture and all those things, we had things, whatever we needed to store in the database, that structure was fixed, that schema was fixed there, right? If I take an example of the bank account, so bank account, user account information there, whatever name, account ID, what the balance is there, and other information was fixed, and one time it is there, and I can keep using those schema to store the values there. So we had that relational database management, RDBMS kind of databases, right? But recent times, you see the growth of the data. If I talk about the Flipkart, I talk about the Amazon, I talk about the streaming websites like Netflix and Amazon, there is so much data that is being created. It is not possible to process that data with the kind of database that we have right now. So the main limitation is that structure is fixed. Once we have created that structure in the table, it's very difficult to add new attributes in there, right? So but the demand of the new data that is being generated, it's the thing that I need to I should be able to add. That flexibility should be there in the database. That is where unstructured data comes into play. So whatever database RDBMS that we have, it is best suited for the structured database that we have, right? But we can store this unstructured thing also, not an issue, but it's not that efficient that we need, right? So for that efficiency, there is new kind of databases that is coming into picture. That is what we say NoSQL database. NoSQL DB, not only structured query language SQL, that is structured query language. NoSQL, not only structured query language, it supports both of the things. So the new requirement that we had for the unstructured data can be fulfilled with this kind of database that we have. So now also there is like advantages and disadvantages of both of these. If I talk about the advantage of the SQL database that we have, it has strong ACID compliance. ACID, when I say ACID, that means I am referring this one, atomicity, consistency, integrity, and durability properties. This RDBMS database is compliant with this format. Complex queries can be executed without any issue, and data integrity issues. Data integrity is going to be there with this SQL kind of database. If I talk about the exact example, if you see Oracle, MySQL databases, there are some example of the relational database. NoSQL database, one example is MongoDB. I can store unstructured data in there. The disadvantage of the SQL databases, like fixed schema that we talked about, limited scalability. Like when we talk about scalability, huge amount of data being data is increasing, it's very difficult to scale this database. Coming to NoSQL databases, the advantage is like flexible schema, horizontal scalability is there, high performance is there with the kind of data that we need with unstructured data, right? So I can now move this arrow to this one so that it's very clear. And disadvantage is that eventual consistency, like with database we had ACID compliance, so data is if something is persisted, it will be immediately available to other parties in. But with the new SQL databases, that is the eventual consistency. It will be available eventually, basically, in some cases. Complex queries cannot be executed. There is limited capabilities around that much, but we do not need for those things. So there are specific things, specific use cases for which we use this one. I hope you got the understanding about this one. So that is about the type of databases that we have, SQL databases and NoSQL databases. Let me draw the arrow in here also so that it's very clear that both of the things we are taking the advantage of in here. Okay, now let's discuss about the performance, like the amount of data that is increasing with the NoSQL databases also and with this database also. So let me clean this up a bit, because this we got the understanding of this one and they're not needed. Okay, so now we have this simple structure in place in here. Reduce it this a bit as well. So whatever write, now I talk about the operations, write and read operations. So let's focus on this one first, RDBMS. Whatever functionality is coming for the write and read, this single database is going to be is taking care of that one. Here we are talking about the huge amount of load that is coming in, and if I talk about the ratio of the write and read, the amount of data that is being created is very different from whatever is being read. Okay, so what I can have one set of database that is taking care of writing part only, and another set of database that is going to take care of the reading part only. So I can have this, that is what we call the replica, right? So this I will say this one as read db, and this one I will call it write db. All right, so all the write cases will be, all the write scenarios will be taken care by the write database. All right, and all the read flows will be taken care by the read replicas in here. बाबू बाहर जाओ. चलो. Okay, so all the read part, I would say. So all, now we have divided the traffic of the write and read. So how the next question comes in, how the data coming in into this read database. So on the back end, asynchronously data is being replicated to these instances as well, right? So async replication. Or whether async or sync, that depends on the scenario. So I can say that simply replication. If whether it needs to be synchronous replication or asynchronous replication, that depends on the requirement actually. So whatever write operation is coming and the data is being created on this write DB, the same set of data will be replicated to the read instances also. What benefits do we get out of this one? That we get the efficiency out of this one, like write is separated from the read one. That is the one benefit that we get out of this one. Another is about high availability that we get out of this one. If somehow there is problem with the write databases, write DB in this one, so there is another replica available, another backup available to take care of the write functionality. So if something goes wrong with this one in here, I can always route the request of the write towards any of the replica that is available in here to take care of the write request. So if anything goes wrong with this one, I can and this connection is not proper in here, I can have this route to the read. One of the read replica will take the role of the write DB in here. So I just have to route that traffic in here. So this is yet another benefit that we get out of this one, that is like high availability. Okay, these are the two advantages that we get whenever we have the different replicas for the write and read. So that is how I can scale our database for the amount of load that is increasing on the server side. Same sort of thing I can do with the NoSQL databases as well in here, right? And the NoSQL databases are there, they are equipped by design that I can have the horizontal scaling around that one, right? So I can have more replicas around this available in here the similar way. Okay, so this is about the replication mechanism, and this also known as master slave architecture. You can say that this is the master instance and these are the slave instances of the database available. So these are the two things and these are the terminologies that I wanted to introduce you, and you got the understanding about this one. At any point in time, if you have any confusion, any question, try to put that in the comment section. I'll try my best to reply to that comment as soon as possible. Coming to the next part that we have, that is sharding. One concept was there, one terminology was there about sharding. So how sharding comes into picture? How sharding comes into picture, right? So let's discuss this scenario. So whatever, let's say we have our application, we have user base of our service or website throughout the world. Basically people from every country are using our services in here, and they are writing the data and they are reading the data from in there. So, and the data from all over the country is being stored in one database here. So if you see the geography entire world, let's say that database is hosted in India and someone is trying to access it with USA, that will take significant amount of time to with compare it with the person who is accessing it from India only. So that will be round trip will be a lot when we are trying to access it with the USA in comparison to India. So what we can do, we can have more copies of the database in here. Basically the write database, it does not matter whatever we are saying it, so all the write databases basically. So I can categorize this one, like what kind of data, what data is going to be there in here, and it's the responsibility of the software, like the layer that put in place. So maybe I can have some routing mechanism in place in here, so that will take care of, let me try to put it in here. Show, give me a minute. So I will just move this a bit so that it sits properly in here. Okay, so let's say I will store the data from USA in 1 dB. I will store the data from the China in 1 dB. I will store the data from the India in another dB. And how this routing will happen, I can have some sort of layer in place that will take care of, so whatever write request coming in based on the geography, it will take care of the routing the data where it is going to be there, right? So this is what is known as sharding. So what criteria we are choosing to separate that data, that depends. In this case, I choose the country as in criteria to have the different databases around that one. Another criteria can be celebrity, if I want to store, I have a particular table right in place, and I have celebrity data around that one. So let's take an example of Instagram. A lot of data is coming in, so let's say some celebrity who has huge number of followers, they are posting something, so the fan out or category, whoever is reading the data will be a lot with comparison who has less follower. So I can have this kind of categorization of the sharding also, and I see how I name it: shard 1, shard 2, shard 3, right? So based on that, I can have different shards available. That is how the write is also optimized very much based on the number of requests that we are getting in here, based on the criteria that we have in place. The same applies for the read DBs also that we have. So I can have those sharding available differently, and the read request can be routed to that as well. That is how sharding come into picture. So I hope I explained you guys the things that I wanted, like which database to use, database replication, database scaling. So vertical scaling is the same thing that we were discussing about in the case of servers. The same server is going to be having increased capacity, like more number of memory and CPU. That is vertical scaling. Horizontal scaling means that we are putting more number of instances with similar capacity, and just routing is going to be taken care by some another layer that is going to be there. So now we have these three layers. This is the web layer, this is the data tier available in place, and this is the API gateway, and this is the client. So now I hope you are getting the picture how it is looking like here. So just reiterating, first client is initiating the request with the DNS. It is getting the IP address of the API gateway. API gateway is routing the functionality to the specific load balancer, whatever it needs to go to, and then if it needs to store that unstructured data, it will call the NoSQL databases, like it wants to store the analytical data like comments, like, dislike and all that. And if needs to store the data that is transactional in nature, like banking or user account information, it will read or write the data from those specific databases in here. That's all about this video. I wanted to cover database, and I hope you got the complete understanding about this one. This will really help us to strengthening our concept about the system design. Next, we are going to talk about cache. End of the day, I want to have improved performance about my system, right? So how cache is going to play the role of in improving the performance of the system. We are going to discuss that in the next video. Till then, take care. Bye bye.